Good morning, good afternoon, good evening, wherever you are in the world. Pleased to welcome you to webinar number 23 of our airfield ground lighting series. This week is on the topic of the measurement of apron and stand floodlighting and how to do it, and the business case for doing it. Why do we need to do these measurements? I'm pleased to have with me today, as ever, Keith Costall, our Director of TMS Training Solutions, owner and Director of Training, who is as known to you all, as one of the world's leading professionals in the field. Also, Tony Smith, member of the Royal Society, inventor of the PAPI, and has represented the UK on numerous panels, including ICAO, and is acknowledged world leader in the field of airfield lighting. Tony and Paul Smith is also with us today. He has developed, in conjunction with Dublin Airport, who have a special mention for today, the Luxometer, the apron and stand floodlighting tester that we have developed in conjunction with Dublin Airport, but we'll talk more of that later. So my name is Robert Shapton. I'm Managing Director of TMS Systems and TMS Training Solutions, and I will be your host today and in fact giving the presentation. So without any further ado, let me get on to the presentation. So why is apron floodlighting so important? Well, the purpose is to facilitate safe operations on an apron, on a de-icing, anti-icing facility, and on a designated isolated aircraft parking position. It's intended to be used at night, and that's intended to be used at night and in reduced visibility. We were discussing this morning, and they've been in operation. This sort of lighting has been in operation now for approximately 80 years. I mean, out of the chaos of the 40s and 50s, when commercial aviation really started to grow exponentially, innovations like apron floodlighting were introduced necessarily to improve visibility, obviously, and make flying safer. A fact I've learned in the course of developing this presentation today is there are more incidents occurring in the aircraft stand area than anywhere else in the airside operations. I guess one, if one thinks about it, you may have worked this out, but I certainly hadn't appreciated it. The fact is that the apron stand area is not an operational aviation area, is not governed by the same rules, not governed by air traffic control. So this is an area where we see more incidents to passengers, staff, and sadly to aircraft as well than anywhere else on the airfield. But at least they're pretty static when these things happen. So these rules are particularly important, and we're going to go into them in somewhat more detail now. The regulations, and this is all posted on the website, so you don't have to write it down. The regulations can be found in ICAO Annex 14, Chapter 5.3, 24.4, in the Aerodrome Design Manual, Part 4. EASA has a CS ADR DSN M750 on apron floodlighting, and of course, for those in the UK, an example of a national standard, UK CAP 168. And the details on apron lighting can be found in Chapter 6. They all state what is briefly summarized in a very short section of Annex 14, that the illuminance, the average illuminance, should be at least the following: horizontal, 20 lux, with a uniformity ratio, which is average to minimum, of not more than 4:1. So that means if the average illuminance is 20 lux, the minimum at any of the measurement points should not be below 5, not be 5 or below, i.e. a ratio of 4:1 or less. or greater. The vertical illuminance similarly should be 20 lux at a height of 2 meters above the apron in relevant directions. Now, we will talk about that again in more detail as we go through the presentation, because there's a lot of there's some quite challenging definitions to be addressed here. So what first of those is vertical illuminance. What is vertical illuminance? It has the average vertical illuminance must be at least 20 lux. So it's a measurement of the amount of light hitting a vertical surface, such as the side of an airplane, in relevant directions. So so how much light is going effectively sideways? So the 2 meter sensor, the sensor that's at 2 meters in height, is measuring the light of vertical illuminance. But in relevant directions can be quite confusing, and there are a number of different national, international methodologies that have interpreted this relevant directions in different ways. So we'll come on to that in more detail. But the first plea we would have to the regulators of you out there, we need to have some clarity in the measurement approach. We need some consistency, because as we've been looking with Keith and Tony and Paul at the various national standards across countries. I've seen Australia, I've seen Ghana, we've looked into Oman, we've looked at the UAE, we've been looking at in Canada, FAA, and of course the UK, and there's some quite different approaches to this measurement in terms of relevant directions. Next is horizontal illuminance. This is the measurement of the amount of light hitting a horizontal surface, such as the pavement. So this is the measurement looking up from the pavement. And very interestingly, when we were discussing this earlier, I think it was Tony that pointed out that the nature of the surface is absolutely critical here, because the high mast is illuminating the pavement, and it makes a great difference to the visibility on that stand if the stand is actually built out of concrete as opposed to asphalt, because the concrete tends to reflect the light up much better than the asphalt, which absorbs the light. The relevant directions also been interpreted in a number of different ways. So none of these are actually wrong, because the regulations don't specify what is the relevant direction. But clarification would be helpful. Should the vertical illuminance measurement be taken with the sensor pointing towards the terminal building? This seems to be the most common method we've come across. So basically, using whatever sensor you may have, pointing it towards the actual terminal, which often is where the floodlighting is installed. Or should it be pointing away from the aircraft? And I know at least a couple of authorities, Oman comes to mind, where the measurement is taken from the aircraft, pointing away from the aircraft. So effectively measuring the light that is shining towards the fuselage of the aircraft itself. Or as some measurements are taken, pointing towards the nearest floodlight mast, because the standards do recommend in sighting floodlights that there should be the light should come from at least 2 sources to minimize shadow. So and of course then there are other directions which are taken. Some approaches go for the measurement that acquires the most light, so get pointed in the direction that is brightest. So a clarification from regulators as to how this should be done would be helpful, and this is certainly a matter that we'll be looking to talk to our colleagues in the regulatory world about. So the next issue is the grid size. This also has been interpreted in different ways. There is no grid size specified in the standard, but there are various regulatory bodies that talk about grid size measurement in terms of measuring light, not specifically to aircraft though. None of the, so no grid measurement is actually wrong, but once again, some clarification, some clarity would be very helpful. Logically, the number of measurement points should be proportionate to the size of the aircraft and stand size. The bigger the stand, the more measurements you get. But interestingly, from the CASA standard, that's the Australian regulator, they have conducted, I think this is based on some work done by Perth Airport. They calculated the measurements based on different grid sizes varying between 2 by 2 meters and 10 by 10 meters, and they measured the horizontal and vertical illuminance on both measures. And if you think about it, it's logical, but I was surprised to learn that the bigger the grid size, so in their example 10 by 10, the lower the average illuminance, both vertical and horizontal. So in fact, the bigger the grid you have, the more conservative your measurement. Now, we're not talking, we're talking just 2 or 3 percentage points. So it doesn't make a huge difference, but it's interesting to note, and also supports the argument that no grid size is actually wrong. But again, standardization of methodology would be helpful, but also some practical means, because clearly, if you're taking 2 by 2 meter measurements, you're measuring an awful number of points, a great number of points, which will take a long time. And of course, stand availability, the potential of having to actually close a stand for a measurement, is a very critical factor for a busy airport. So just for your reference, and I'm not going to go into these in detail, we included in my presentation the ICAO aircraft code reference table, which shows that for each code of aircraft, A being the smallest, F being the largest, the wingspan sizes. It also shows outer main gear wheel span and main minimum clearance distance. But the thing we're most interested in is wingspan, because that's the basis for the size of the aircraft stand, A to F. And then for those of you working to FAA standard, we have the imperial measurements, which are noted group 1 to 6, same measurements as you can see from the meters there, but stated in feet instead of meters. So those are the aircraft code reference tables that we have worked to. Ultimately, this is all about measurement. We're talking about safety and compliance, and you can't manage anything with anything that you don't measure. You have to have accurate and repeatable measurements when you're monitoring the performance of your aircraft stands. And we know what the standard must be: 20 lux vertical average, 20 lux horizontal average, with the ratio 4:1. But how do you know it's that without a measurement and without an accurate measurement? So the first thing about accurate repeatable measurements, you get the same result every time you do it. And it should be the same regardless of, the measurement should be accurate regardless of light source. It is handheld photometers are generally, I've spoken to the industry professionals, the handheld photometers that you buy are generally calibrated to a halogen light source. However, most stands are either LED, sodium, or metal halide. So I would recommend, clearly for an accurate measurement, you need a device that is calibrated to the specific light source of the stand that is being measured. you want to have a repeatable measurement. To achieve repeatability, you need to have a good sensor in the first place, but you also need measurement at the same grid points. I know some approach it with putting traffic cones out and other markers. These represent, of course, the risk of FOD. But you need to identify a method of reaching the same grid points on a repeatable basis, because measurement over time is key. A lot of airports measure 6 monthly or annually. What you need to be able to do is to compare the measurements over time and see if they're deteriorating, and then understand why they're deteriorating, and carry out preventative maintenance or predictive maintenance based on those results, potentially even using AI that we were talking about in the last TMS Tuesday. Based on the results, anticipate what the potential results will be in the future and carry out your maintenance accordingly. So whether that is cleaning, relamping, or replacing even. The measurements also must be in the same direction, obviously, to achieve repeatability. So they should be at the same height. They should be actually vertical measurements, parallel to the pavement itself. Quite difficult with a handheld photometer, but that is what we have to try and achieve. The second requirement we've had from our customers is the measurement should be quick and easy to the process should be quick and easy. Less than 5 minutes per stand to maximize stand availability. I understand from our colleagues at Dublin Airport that a code C stand takes almost 30 minutes. With that length of time, you have to actually close the stand to operations, obviously. So less than 5 minutes is good. No other equipment required. So we ideally do not want to be placing markers all over the stand, which could become FOD. You want to have a single operator, because it takes a lot of time to do this, and using multiple people, one or more than one person, will take a lot of time. Digital recording and not paper-based recording, again, is much easier to manage data, much more efficient if the recordings can be made digitally, because then they can be used online to provide you the analysis of the average illuminance, vertical and horizontal, to compare it to the standard, to map it, to identify the problem areas, and then also to develop trends over time to understand better what the problems might be. And then finally, you want immediate real-time results, so that ideally such that when you complete the measurement on the stand, you can immediately see if it passes or fails, and you can use that opportunity to try and interpret what might be the cause of that result, that failure, to better understand it and to plan any remedial actions to address a problem if there is one. Now coming on to what's happened over time is we have annual user meetings where our customers get together and we talk about the industry, we talk about airfield lighting, we talk about the technologies, and of course we talk about the latest tools and developments we have within MALMS. Now, this is how our apron and stand testing equipment evolved, because our customers had been telling us that they wanted to have some means to better measure the aircraft stands. And so when I had a call from Sean McKessie at Dublin Airport to that they'd come up with the idea for their Luxometer, as they called it, christened it there. I was very interested. So I visited him and Joe Roach in Dublin, and they told me how they'd collaborated. They'd had a sort of a hackathon, I think it was called, at Dublin City University, where local tech companies had got together and had come up with, spent a weekend developing and trying out new technologies with a view to seeing if they could come up with some solve any problems for industry. And Dublin Airport had an issue with stand measurement because they were experiencing an increased number of litigious claims, legal claims against the airport from people having slips and trips coming off the aircraft. And I mean, as if it wasn't obvious, the cause, they were blaming the lighting. We all know it's Guinness, but at the time they believed it was the airfield lighting. So they came up with a solution to measure the lighting. Now, this was done over the course of a weekend, and it was not a commercial product. Very much, I think the clue is in the name, a hackathon. It was built up of parts taken from other instruments, items, and tools, put very much in a prototype environment at the university. But what they came up with was a very good concept and had all of the elements of something that could be commercialized. So they approached us to continue the research and development and design a commercial product that we could offer to the industry as a whole. And indeed, we have a commercial arrangement whereby Dublin Airport benefits from the future sales of the Luxometer. So this prototype was developed, and we've since taken that and developed it into a commercial product that integrates into the MALMS suite of products. Just to be on the fair side, I'm aware of two other products. There are other products out there. So in fairness and openness, there are other solutions out there. But we've developed something based on the Dublin design that we believe best fits the needs of the aviation community. It's called the MALMS Luxometer, and it's designed to measure stands and apron lighting for compliance with the standards that we've discussed already. Very simple to use was one of our first criteria. When you take the device and switch it on, you go to the head of a stand, and using GPS, it will identify the stands within GPS range, and the user simply identifies the I'm just looking at my colleague here. Have we got the stand picture on your screen?
Yeah.
You have, right. It's your machine, I'm afraid. So we identify the stand, then you highlight the stand you're actually standing at, and you will and then you will start the process. An arrow will appear, and you walk in a straight line up the center line of that stand, leading to the leading away from the head of the stand, and that will take you to the points in the grid. Now, we've designed the system so the number of grid points will vary according to the methodology you choose. So whether you are working according to CASA in Australia, the Oman standard, the Ghanaian standards, the standards specified I've seen in Halifax in Canada, so Transport Canada, the FAA and or CAA, you will follow a grid methodology. This is actually designed on the midstream methodology. You may have seen some of their webinars in the recent past. So thank you to Midstream Lighting, whose grid we have actually employed in this particular example. So you follow the line, the center line of the away from the head of the stand. It counts down the distance to the next point, and then when you reach the point, it will either say carry straight on to the next measurement, or turn left or turn right. It's completely intuitive. You just point. You just point the system. Just a moment, please. You just point the system. Sorry. You just point the system. Please turn it off. You just point the system, and it will take you to the next point in the aircraft in the grid. This is the design for the 15-point grid, which is used for aircraft categories A, B, C, and D. So you start off from the head of the stand in this area here, marked marked by a T. You follow the red line through point 1, 2, 3, 4, 5. It will indicate go left, and you follow it to point 6, where it indicate go left. You follow 7, 8, 9, 10, and then it will point you left again. You go all the way across. It's counting down the distance, so you know not to turn, and when you get your next direction. And at point 11, it will give you turn left, and you follow to the top here at point 15, where you will get an indication to say 0 distance, and you've reached the end. Just for illustration, for code E and F, we have the 25-point grid, again according to the midstream methodology, where you take the center line, turn left, go to point 6, turn left, turn right, point 11, turn right to point 15, and follow the remaining points to 25, when you will get a message to say stand 101, the finish flag, distance 0, points 15. So this indicates this is for class C, wingspan 35, length 39. So you've completed the test, and then after a few seconds, the screen will give you a result of either okay or not good. So it's either green for pass, red for fail, and you can see from the measurement for the pass, you have an average vertical lux measurement of 31.9, which is clearly above 20, and the average vertical horizontal measurement 32.8, clearly again above 20. The ratio max to min 2.28, so that's less than 4:1 on uniformity, and the stand has passed. In this particular case on the right, again, the individual lux measurements, the horizontal is 33.2, which is a pass, and the vertical measurement is 31.0, but the uniformity ratio is over 4:1. Now, that means the in this particular case, there will be one of the measurements below, below around 7 lux, and therefore it doesn't achieve that ratio of 4:1, so it's a fail. The results are presented in this format with a simple report. Well, you have a report summarizing all of the results, then you click on any one of those results to give you the individual stand measurements. You have a unique inspection ID, the vertical and the horizontal measurement, the minimum illuminance ratio in lux, which is 9.25, which gives you a ratio of 2.9:1, which is, of course is less than 4:1, therefore is a pass. You have a timestamp for when the test was taken. You have it was a 15-point inspection, so you can see the method that was used. The type of light which we pre-configure into the system was a sodium, and of course it's a pass. The individual measurements, horizontal and vertical, are listed below, and the individual points here. So point 1 corresponds to point 1 here. You can see vertical 49.66, horizontal 49.66, vertical 72.04. So each measurement is provided, so you can see the pass and fail spots over the course of the test, so you can identify action. Also, to help the measurer help interpret the measurements, you can see we highlight you have the brighter areas, a bit like the isocandela diagrams with a photometric test. The brighter beams surround the brighter light measurements, lux measurements. So this point here, which is point 10, is the brightest area, and the light reduces the further away you gravitate away from this corner of the stand. And if you look closely, just by chance, we have an aircraft parked adjacent to this stand in the next stand, and you can see from the shadow that it's casting that there's a light positioned somewhere in this area. So you can imagine the mast is here. So this is why the brighter light is in the proximity of point 10 of the measurement in this corner of the stand, and the darker points are over here in the furthest extent and furthest away from the actual floodlight, which must be situated in this approximate area. So, to summarize, the whole point of this all is for safety and compliance. Obviously, this is mandatory. It's not, and you have no idea if the stand is compliant if you're operating safely without the measurements. And this is what we have provide to you with the Luxometer. You need accurate and repeatable measurements, of course, and that's regardless of light source. So you need one device that can measure a metal halide, can measure a sodium, can measure an LED stand. The measurements must, of course, be quick and easy to perform. As I said before, in Dublin, a Coach C was taking them 25 minutes, but now it's taking them 2 minutes and 30 seconds. No stand closure should be required, because that has an impact on operations. We know from our testing how difficult it is to get access to stands at all. So we really want to minimize stand closures, and a 2 minute 30-second measurement considerably assists that. Digital recording and not paper-based. Avoid time wasting man-hours on compiling information. You also don't have the information available for trend analysis. People ask how frequently you need to test the stands. Well, ultimately, that depends on the performance over time. So if you've got comparative measurements, you can see what the deterioration is. You can figure out how often you need to change lamps, how often you need to clean the floodlights, perform maintenance, and then you can plan your maintenance schedule accordingly, as you do with your signs, with your PAPIs, and your runway lights. The risk of FOD is eliminated using a device such as the Luxometer, because it's a compact, it's a lightweight tool, fits in a small carry case, and there's nothing to be screwed together. It just clips using internally fitted clips, so there's nothing that could fall off or could become FOD. The productivity of inspections also greatly increased because it's so quick and easy to use. It's a single man operation and it's intuitive. It provides an airport with a platform to demonstrate compliance. Using the MALMS dashboard, you can have a window to show which shows the stands have been tested in the prescribed interval, be it 6 months or 1 year, whatever the testing schedule in your airport plan specifies. You can show that A, the lights have been tested, and B, that they are compliant. And if there are any non-compliances, you have a method to drill down to the individual light and see what the problems or issues might be. but hopefully it's just a method to prove to any regulator that comes to audit your airport that the standards have all been tested and they're all compliant. And finally, you can never ignore the need to demonstrate financial savings. You're saving time to actually perform the tests. You're increased stand availability by not having to close them. You're improving productivity because it's a very quick and efficient method of measuring. There's no desk work, calculating spreadsheets, doing this measurement afterwards because it's done automatically on the system and provided immediately on the cloud. And the business case for at least 2 airports I've spoken to has been on insurance and reduced insurance and litigation costs, because you are able to demonstrate that the aircraft stand was lit properly in case anybody makes a claim against the airport for slipping or tripping coming off an aircraft. And secondly, you're able to provide evidence that the stand is lit correctly, because there are a lot of unfortunately, as I said, most accidents occur in the stand areas of an airport before you get onto the controlled areas where vehicles are damaging planes, frankly, and there's been a couple of instances where service vehicles have hit aircraft and have successfully claimed non-responsibility because the stand was inadequately lit. So there's a financial case there. Investing in a Luxometer will provide a rapid return on investment. And so we're going to come on to your questions now. But before I do, and I know some of you will have other meetings to go to, I should just point out that at the end of this webinar, you will receive a questionnaire, which would be grateful if you could complete and give us your feedback on today's webinar. And in particular, can you give us any suggestions for future webinars? These are for your benefit. We want to do what you would like. We would like to present to you the information and topic that you're interested in, and therefore this is why we're in the next webinar on June the 30th, on August the 30th. We'll be presenting on instrument runway visual range, IRVR, and the importance of runway lighting to its calculation. Not many people know that the runway lighting intensity is inherent to the calculation of IRVR. So it's very important that the runway lighting meets the levels specified in your IRVR calculation. Otherwise, your runway visual range will be overstated, and that obviously would be very dangerous. So we'll be telling you all you need to know about that next month. But today we're talking about stand and apron lighting, and so I'd like to invite your questions, please. If I could hand over now to our expert panel of Keith Costal, Tony Smith, and Paul Smith, not related. But so if I could hand over to you now. Thank you very much for your time, and I will stop sharing. Right then, gentlemen, here's Paul Smith. One of the first questions, if you could unmute, please, Keith. One of the first questions we have here is concerning the direction of measurement. Can you give us a bit of a background to the standard itself? What was the intention when the standard was developed, Tony?
Well, I think I was still in nappies when that was originally. After all, it was an obvious thing to do at airports where the aircraft was planing and deplaning passengers, just as any other public area, whether it be the street or wherever it is. have some floodlighting so people could, in the dark, walk about and not bump into things and fall over things, and at the same time provide some light for aircraft maintenance and vehicles close to the airport. And my understanding is that, of course, there's been knowledge of how to do floodlighting generally for all of this time. And if you, for example, the Illuminating Engineering Society of North America publishes a big, thick volume on lighting, and it has whole chapters. There's one big chapter, of course, on aviation lighting. There's a whole chapter in there on floodlighting, and it gives you all good methods of how to calculate what size of light and so on you need to provide what illumination levels and the lux levels that are appropriate for different sorts of building, whether it be a city hall, town hall, a railway station, whatever it is. The information is there. And my belief is that, if you like, that knowledge was carried across into the aviation world. And when ICAO started to put together its standards and recommended practices after 1945, it took information from practitioners and just added it into the standards. I don't think it was properly researched to see if that was perhaps a direct read across was the right thing to do. And hence, I think now, when you've been looking at TMS, there are all sorts of questions as to whether the adequacy of the methodology is actually good enough. Because, for example, in the EASA and other definitions, it talks about safety, operations safely. Well, safety, if you're trying to walk about, is one thing, avoiding trip hazards and bumping into other people. If you're driving vehicles, there's a different sort of safety there. But if you are doing aircraft maintenance, there are safety issues there, like, for example, being able to, in some cases, correctly read color coding, which may be associated with a connector or something. And so, in fact, the level of illumination, so you see the correct colors, but also the light source, as a sodium source, of course, can significantly distort the apparent color of paint markings or covering on wiring, for example. So I think that actually what you've been revealing is this whole area could really do with a nice bit of research to actually identify what really are the requirements, the modern requirements across the board, all these end users, bearing in mind, of course, that this is not in the movement area or the maneuvering area of the air. It's not under the control of air traffic. It's airside safety is the driving force for this.
Thank you, Tony. This feeds on nicely to a question we have here. Is 20 lux adequate? Do you have any thoughts on that, Keith, Tony, Paul?
Well, maybe I can jump in there. That's a question that I've frequently been asked, associated with the floodlights. Where did 20 lux come from? I mean, basically, we go back to the health and safety standards in industry for the amount of light required for safe working, and 20 lux had been established. Now, the history behind the 20 lux, and I think Tony has already, and you, Robert, had already indicated, then what about the pavement surface? Is it concrete, which is reflective because of its color, or is it asphalt, which is dark, which will absorb light?
Yes.
And so I think this whole issue of stand lighting, not just the standards that exist today, which you refer to there, the 20 lux and the 41 ratio, we need to take into due consideration these other factors, such as the pavement type, such as working underneath the wing structure, etc. So that's my my consideration.
Well, I think you've all touched on sort of lots of different aspects of exactly the same thing, is that there are so many factors that are not considered in the existing regulations, and sort of wishing to play devil's advocate, you could almost suggest that one of the measurements that ought to be taken is pointing down, so that you are measuring the reflected light that would be available to anybody working underneath an aeroplane, because most of the lights that are on the apron are going to be above the wing. So your work environment is always going to be shadowed. So you're going to be working on reflected light from other surfaces.
Well, actually, Paul, you've now opened up an area where, when I was still part of the visual aids panel, I seem to remember recalling when we did briefly talk about floodlight for some reason, but I didn't think that the measurement should be illuminance, because that's the amount of light falling on a surface. And depending on the surface and its reflectivity, is what you see luminance. You don't see the illuminance, you see the luminance of the surface. It's identical in a way to your lit sign. It's the brightness of the surface that determines what you see. And these requirements could be specified in terms of luminance rather than illuminance. But what I would say is, we've got these specifications at the moment. They're a good starting point, and this equipment does at least put some standardization in and some sort of measure that is credible into the situation. I just hope that the specifications could be enhanced in time, but I think this is a very good start to have a piece of equipment like this, where at least there's a credibility to what is being measured.
Yes, so thank you for that. It's all very good points. So standardization is a theme that's coming through very loud and clear from this, and the need for research. In my experience, the FAA seem to be, and I apologies if I'm speaking out of turn here, but the impression I get is the FAA seem to be the world's leaders in terms of research now, in terms of aviation technologies for safety and compliance at airports. Is that a fair comment, or am I being harsh? Keith?
So sorry, I was answering one of the questions live.
I'm just saying, my impression is in traveling the world, the FAA seems to be the leaders in the tech center in terms of evaluating and developing, safety technologies relating to the airfield. And if I'm right on that, which I think I am, but please feel free to correct me if I'm not. I think practically we should be making representations to the FAA to potentially look into this some more. I know
the international authority in this area, of course, is ICAO, and the ICAO have a visual aids working group, panel, whatever it is called nowadays. But of course, in the absence of the leading international standards, then of course national authorities have taken their own interpretations, and this is why we see in the documentation on recommendations from the national authorities the variations that exist. And whilst, yes, I think the FAA, and what I will say about the FAA is that they are very, very proactive in such things, and also they share their findings for free, in very good advisory circulars or engineering bulletins.
Yes, there is a document RP37 that was been developed by I think the lead person on that was Richard Larive, which he's done a lot of work on this area. But certainly I think there's scope for this to be, all of this to be reviewed. I know they're very busy, and it seemed, but it'd be very good, I think, if the Visual Aids Working Group could take this up as a project to look at the standard in more depth, to consider it, because as with all visual aids, the environment has changed since these standards were developed. The technologies have changed. So in particular, I've seen product demonstrations on floodlighting products, and I've noted that with the LED light source, they're far better able to isolate specific areas such as a stand, rather than the traditional floodlighting, which basically scattered the light far and wide. So it's much more targeted. I think the opportunities to minimize glare are much greater with LED lighting. But then similarly, the requirements need to be looked at, and this technology potentially harnessed better to serve the needs of the users of aircraft stands. So, for example, I'm told, and I was told once, that a lot of refueling takes place underneath the wing of an aircraft, in which case there's pretty much, floodlighting is pretty useless, I would say, underneath the wing. So is that right, Tony?
Well, that's sort of what that was why I wanted to use at least Luminance
Yes.
on the surfaces, because that does, in fact, and I was telling you the story earlier, wasn't it, about two parking lots made to the same Illuminance levels, one concrete and the other tarmac, and the users of those car parks described one as well lit and the other one as quite dangerous. In other words, the tarmac one appeared very dim and a miserable place to be. But the same amount of illuminance was going onto the surface.
What about the vertical, the vertical measurement, the direction of the measurement, the differing methodologies? Do you have any preference, or do you think?
Well, what I would say is, I think we're scratching around. We haven't actually done enough work. Everything, as to what is done in more general practice is reflected in what we've got. And the manufacturers have brought along. I think it's true in the floodlighting area with ICAO. It was true of the obstacle lighting, obstruction lighting. What actually went into the ICAO documentation was the best efforts of the manufacturers at that time, what they could make conveniently. And this is much driven by the American approach, which tends to be a runoff between a number of engineering companies and then a sort of beauty contest, which one we like the best, rather than starting with, as a scientist, start with the fundamental principles of what you're trying to achieve, write a specification, then ask the engineers to meet it. And sometimes what you then get is what the manufacturers conveniently want to sell you without too much trouble, which may not properly meet the requirement. And I think that's what we've got here. It's got a very long history, but I don't think the requirements have ever been properly researched as to what is needed, and certainly not updated, as you say, for modern aviation.
One of the things that I've seen, Tony, as well, is that there is now software available for people to actually design their lighting to have the particular performance that they're after. And I've been on some old aprons where there've been a huge number of metal halide lights on the top of a mast, and I kind of asked the engineers I was with, it's like how did that design come about? And basically the answer was, well, they just stuffed as many lights up there as they could to give the level of light that they thought was appropriate. And right next to that was a brand new piece of apron with LED lighting on, really nicely, evenly illuminated, and that had been designed with some specialist software in mind. So there's now advances not only in the lighting technology, but in the technology of designing the lighting to do what's needed to be done.
You're absolutely right, Paul. The last 15 or more years, the ability to design and manufacture lights that properly meet the requirement and don't produce glare. I mean, one of the biggest places where that's all evident is modern street lighting. The old street lights, if you approached a lit area from an unlit area coming down the road, you saw all these light sources in the sky. Now you don't see them. You see the ground or the area that you're driving through illuminated when you get there, but you haven't got all this night sky full of useless light. And the optical designers can do that now. They can effectively, what they're doing is doing what the theatre companies have done for generations: produce spotlights where there's very little light outside the beam that you specify.
Yes. You just raised, just maybe thinking back. I mean, often nowadays when I drive around, you'll see many motorways and street lighting systems where the lights are turned off to save money, principally to save money. It may be also environmentally better and everything else, but I think the main driver is to save money. And it reminds me that in the last year, I've been to 2 airports, where one airport, the signs, the masts failed because the airport, because of COVID, had taken the decision not to relamp the normal service interval, and therefore the light output had deteriorated from those light sources. So that was one area of a I can understand the motivation, but the lighting was non-compliant. So I would say a false economy. In another airport, the airport had actually not switched on or not connected some of the lamps. They were reduced. They weren't all working on the floodlights. Only half the floodlight was working. And I don't know how the floodlights, how you do that, but that was, I was told that was a conscious decision to save money. And this is a bit like I've seen on photometric tests. I've seen where the CCR for 100% has been set not to 6.6 amp, it's been set to, for example, 6.4 amps to save money. These are dangerous economies, because when called upon, you know, if the lighting is non-compliant, it's frankly unacceptable if you can't get the light, if you can't get a compliant light output from the system concerned. So I don't know if you've ever seen that or heard of that.
Oh, the deliberate underrunning of light sources, tungsten halogen, was absolutely rife back in the 70s when I first looked at, you know, where all this started in monitoring. I went to, you know, airports that were licensed and saw outputs on runway center lines and taxiways which were 10% of the book values, and the contamination was one of the large issues. But one of the others was that at the level of the local maintenance engineer, without reference to anybody, was adjusting the current down until the number of light bulbs per night that he had to change was commensurate with the number of persons he got to change the lights.
Right. Well, so yes. Well, that again, I hate to say it, but we all can understand what's going on here. But ultimately, it's a false economy, because these lights are one of the principal reasons there is for low visibility conditions when their output is absolutely critical to safety. And if you do that, when called upon, they will not provide the visual guidance provided. They will not be seen. And
one of the things I would say here, it's a favorite little statement of mine, that if you think that compliance, if you think that maintenance is expensive, try an accident.
Absolutely.
Just
So,
one-
go on, Keith. Sorry, Tony.
Just one other thing that's occurred to me as we've discussed this. If you were going to enhance the information, it's still a recommended practice, of course, it's not a standard. But if you're going to do some work and improve the recommended practice, I would say there'd be a useful note to the operator of any equipment doing the measurement to be aware of the actual meteorological visibility in which you are doing it. And I say this, I tell you, it's an old story, but it goes back to the time when colour television was coming into common use in the UK, and all the major football stadia were putting in high levels of floodlighting. I think it was 300 lux was the requirement at the centre of the field that the coloured television cameras required. And one of our major manufacturers got the contract to do our national stadium at Wembley. And they did all their calculations, switched it all on, and did a demonstration one night, and they were deficient by 15–20% of the numbers. Now, they are very experienced, they've done it many times, and they came to us and said, we don't, talking to us, some reason, I don't know what, said, what was the visibility? And they said, well, we just did it at night time. I said, but what was the visibility? Go to the Met records, and the visibility was about 2 miles. Now, in a city, an urban city, you wouldn't say other than clear visibility. But that amount of atmospheric attenuation was sufficient to account for the loss of light. So it doesn't matter what conditions you're going to make these measurements in. And that should be, there should be a note and some guidance. No, do it on a clear night.
Yeah. So
that also brings us to the periodicity again. The questions that have come up, in writing on the Q&A is, what periodicity should we adopt for measuring the light outputs for the stand lights? Well, I'll refer to last week's webinar of predictive maintenance, where we spoke about condition and performance-based maintenance. We measure, we record, we analyze the results, and the periodicity is chosen according to those results.
Yeah.
And having them recorded digitally, of course, will greatly aid you in your analysis and reaching a conclusion. So look, guys, I've just for your information, I've just been looking. Keith has been busily answering lots and lots of questions. There's more than a dozen questions I see you've answered there. We will post all those questions and answers on our website rather than just read them out now, as I see we're already over time. But I'd like
on those, Robert, on the questions, they're very, very quick. We will relook at the questions, and if there is additional information from any of us, we will add the additional information online.
Okay, thank you very much, Keith. Really appreciate that. So look, thank you very much, everyone, for participating, joining us today. Thank you. Special thanks to Tony, Keith, and Paul for their contributions in answering your questions and joining me on this webinar. As I said, please fill in the webinar, the questionnaire that you will receive after this webinar. Thank you all very much for your participation. A recording will be put online on tmstrainingsolutions.com, where you can look back at today's and several other, all of our other webinar information or presentations, just to refresh your knowledge and understanding if it's helpful to you. But thank you very much for today. We look forward to seeing you all on the 30th of August when we will be discussing IRVR, the importance of airfield lighting to that measurement, and how it all works and our responsibilities in maintaining it. So thank you and have a nice rest of the week. Thank you for joining us. Bye.
Thank you.
Bye.